Good morning. So our previous lesson we had spoken about the concept of slope, right? We introduced the concept of slope as the steepness of a line, and we said we can quantify that with a number by measuring, by counting the rise over the run, right? So from one point to the next, we'd be able to count the rise, we'd be able to count the run. The rise is the numerator, the run is the denominator. If we rise up, the rise is positive. If we rise down, it's negative. If we run to the right, the run is positive. If we run to the left, it's going to be negative. So I'm going to bypass the do now just so we have a little bit more time to dedicate to the actual lesson. And let's just do a little recap of what we did yesterday, right? Find the slope of this line. Well, in order to find the slope of this line, I need some points. So I'm going to identify some coordinates on this line. And we said I can use either of them, any pair. But we said it's probably going to work best if I take two consecutive points because then I'm not going to have to simplify my slope, right? So there's my rise over my run. Now the first thing we should do is we should look at this line, right? We should see that it's increasing from left to right. So we know the slope should be positive. Now if I am looking at my rise, I'm going up 1, so that's positive 1. And I'm running 2 to the right, so that's positive 2. So my slope, which is my rise over my run, should be equal to positive 1/2. Now, if you decided that you wanted to do something a little bit different, right? If you wanted to choose 2 points that are a little bit further away from each other, right? That's fine. So I'm going to rise positive 4, and I'm going to run positive 8. So my rise over run here would be 4/8, which is going to be half. So what we're going to look at today, right? So let's first review. You have this in your notes already from the last lesson, so you don't have to copy it again, right? We said the slope describes its steepness. We refer to it as the rise over the run. Now, is it possible that instead of having to measure every time, because let's say we didn't have any graph paper in front of us and somebody just said, well, there's 2 points on this line, right? There's, let's take these two, right? There's -3, -4. And there's this point here, which is 5, 0. Right? Could you find the rise and the run just from points? Forget about this graph. And we'd say, yeah, I could probably do that, right? If these are my x coordinates and these are my y coordinates, then to get from -4 to positive, to 0, 0 doesn't have a sign, but to get from -4 to 0, I would have to go up 4. And on my x-axis, to get from -3 all the way out to positive 5, I'd have to go right 8. So I get 4/8, which we said was half. So what was I able to do? I was able to find the slope with just the points, without the graph. And we said, well, if that's the case, then there should be a formula, right, that does exactly what I just did, subtracts those coordinates. And of course there is, and it's called the slope formula. Okay, very, very, very important formula. So make sure we have this in our notes. Okay, so this is something that not that I'm so worried about state tests or regents or anything like that this year, but this is one of those formulas that they expect you to know going forward. Whether it's for 8th grade math or Algebra 1 in 9th grade or geometry, this is a formula that you will use often. You will use this for the next 3 or 4 years, and it's pretty simple. The change in y is the y2 minus y1. y2 just means your second y coordinate, and y1 is your first y coordinate. Then the denominator is x2 minus x1. Again, your second x coordinate minus your first x coordinate. All right, so those numbers are not exponents. They are what are called subscripts. Subscripts denote order. They tell you the first, the second, the third, or in this case, just the first and the second. So let's see what that would look like. So yesterday, we did this, right? We looked at these points, and we measured the rise over the run. And when I measured the rise, I went up 5. And when I measured the run, I went 4 to the right, which was a slope of 5/4. Now let's do this using the slope formula. So this first coordinate down here is 1, 2. And this coordinate up here is 5, 7. Now when we're using the slope formula, what we do is we decide which one of these is going to be coordinate 1 and coordinate 2. And it makes absolutely no difference. So we're going to decide which coordinate is which, and it honestly doesn't matter. I'm going to show you both ways. So let's say I want this to be my first coordinate, and I want this to be my second coordinate. Okay? So if that's the case, if this is my first coordinate, this is my x coordinate 1, this is my y coordinate 1, this is my x coordinate 2, this is my y coordinate 2. So when I look at my formula, y2 minus y1, my y2 is 7, my y1 is 2, my x2 is 5, and my x1 is 1. So I get 5/4. I get exactly the same thing I got with our previous lesson by measuring, right? And I can check it by measuring, of course, right? What did I do? I went up 5. Sorry, that's so crooked. And then I went 4 to the right. So I rose 5 and I ran 4. But again, the usefulness of the formula is we don't need a graph in front of us. We don't need a coordinate plane. We can do this on a piece of loose leaf. We could do it in our head. So this one, when we did it yesterday, we got -3/2. So let's do the same application. So let's say let's get back to the last one doing it the other way. So let's say you decided to make this coordinate 2 and make this coordinate 1. Well, what's going to happen? Well, now when I use the formula, I'm going to get 2 minus 7 divided by 1 minus 5. So 2 minus 7 is -5. 1 minus 5 is -4. What happens when we divide two negative numbers? The quotient is positive. So you're going to end up with the same slope no matter how you take it. But what you can't do is you can't mix and match. You can't say, well, I'm going to use 1 as my x1, but I'm going to use 2 as my y2. In other words, if you were choosing this coordinate. Okay, if that's coordinate 1, it's x1, y1. If it's coordinate 2, it's x2, y2, but you can't mix and match them. So let's take a look here, right? So I've got this point, which is 4, 3. And I've got this point, which is 2, 6. So let's say I want to make this coordinate 1 and coordinate 2. So if this is coordinate 1, that's my x1, that's my y1, and this becomes my x2 and my y2. So when I use my slope formula right here, I do y2 minus y1, which is 3 minus 6. And I do x2 minus x1, which is 4 minus 2. So I'm going to get -3 divided by 2, which we can simply express as -3/2. Again, we said when the slope is negative, it's best just to bring the negative outside. Now, if the numerator and denominator are negative, my quotient will be positive. But if either the numerator or denominator is negative, it really just means the fraction is negative. Okay, so let's take a look at these with just coordinates. Okay, find the slope of the line passing through these points. Okay, so I'm going to call this coordinate 1 and 2, which means I'm going to have my x1 and my y1, and my x2 and my y2. So my y2 minus y1 here is going to be 4 minus 1, and my x2 minus x1 is going to be 6 minus 2. So 4 minus 1 is 3, 6 minus 2 is 4. My slope should be 3/4. Now, if you did it the other way, you'd have 1 minus 4 divided by 2 minus 6, which is -3 -4, which is also 3/4. Okay, if we look at the next one, I'm going to be consistent. I'm going to call this coordinate 1 and 2, x1, y1, x2, y2. So my y2 minus y1 becomes 0 minus 6. Now my x2 minus x1 becomes 10 minus 0. So I'm looking at -6/10. So if I divide by 2, I get -3/5, which we can simply call -3/5. If I look at the bottom one, we have to be very, very, very careful when there's negatives, particularly negatives for our second values. All right, so let's take a look. I've got x1, y1, I've got x2, y2. So again, we're going to be really careful with those negatives. So y2 minus y1 is 2 minus -4. So yes, guys, we are going to need these parentheses. If they are not there, I can almost guarantee we're going to be making mistakes. 2 minus parentheses -4, which means my denominator is going to be 5 minus parentheses -3. So 2 minus -4 becomes 2 plus +4, which is 6. 5 minus -3 becomes 5 plus 3, which is 8. And 6/8 will simplify to 3/4. But again, guys, really important that we're careful with those negatives and we use parentheses for any of the negatives. So guys, this is your now try. So we're going to pause the video. Number 4 is a challenge. Okay, so I don't expect necessarily that we'll all be able to work out number 4 because I didn't model it. But definitely everyone should be able to do numbers 1, 2, and 3. So let's go over it. So if this is coordinate 1 and coordinate 2, and I'm gonna keep these the same for all of them. I'm gonna use x1, y1, and x2, y2 here. My formula is y2 minus y1 over x2 minus x1. So for the first one, we get 9 minus 3 divided by 8 minus 6, which is going to be 6 halves, which is 3. Okay, for my second one, I'll put that down here. My y2 minus y1 is 4 minus 2. My x2 minus x1 is 7 minus 12, which is going to give me 2 divide negative 5, which I would prefer to express as negative 2/5. For my third one, and again, I'll label it again, but what I have in blue up at the top is going to be consistent for all of them, right? x1, y1, x2, y2. So my y2 minus y1 is 3 minus negative 4. My x2 minus x1 is 4 minus negative 10. So 3 minus negative 4 becomes 3 plus positive 4, which is 7. 4 minus negative 10 becomes 4 plus positive 10, which is 14. And 7/14 can be simplified as 1/2. All right, let's see what we can do for number 4. So they're giving us the slope, and they're giving us some points. So again, this is a lot harder. This was really kind of just to serve as a challenge. So if you had a lot of trouble with this, I understand because I didn't model it. x1, y1, and x2, y2. So when I use my slope formula, I get y2 minus y1 divided by x2 minus x1, except x2 is unknown, so my x2 is just going to be x. Except instead of the slope being unknown, I know the slope is equal to 3, so I can say that the slope is equal to 3 over 1. So when I actually do this out, I get 18 minus 12 is 6, divided by x minus 7 is equal to 3 over 1. So now I'm going to think back to when we cross multiplied, when we solve proportions. So I'm going to cross multiply. So I've got 3 groups of x minus 7 is equal to 1 group of 6. So 3x minus 21 equals 6. So 3x equals 27. And x is 9. So now if you were to take these points, 9, 18, and 7, 12, and you were to use the slope formula, you would get a slope of 3. That would be our check. But again, that's a little bit of a higher level application. So I know not everyone's there yet, but I did want to give you something as a little challenge because the formula itself is a little bit dry, right? Subtract, subtract, divide, subtract, subtract, divide. It's nice to see if we can do kind of other things, kind of extensions of that using the formula. All right, guys, so that's your homework. We're doing all 8, right? Regardless of color, we're going to do numbers 1 through 8. Now, sometimes we're going to end up with 0 and undefined. Now, I didn't really have time because I wanted to keep this fairly brief since there's a bunch of questions. Not that the homework is long, but if you have something, let's say where let's look at number 3, where your change in y is 0, just so we're clear. If you have something like 0 divided by 5, that would be equal to 0. Whereas if we had something like, let's say, 5 divided by 0, that would be undefined. So you will see both of these in your homework. So just to be clear about the homework, if your numerator is 0, 0 divided by anything other than 0, of course, is going to be 0, whereas 5 divided by 0, we can't do. We can't divide by 0. We call that undefined. So let's make sure that when we see that in our homework, we're labeling those appropriately. And as always, guys, questions, comments, concerns, you upload your homework, post a comment on Google Classroom, and I'll get back to you as soon as I can.